Hello, here is another couple of examples using density and moles. These are a little more complicated. The density of water, these are on page 60, oh, not 68, 70, page 70. The density of water is 1.00 grams per milliliter at 4 degrees Celsius. How many water molecules are present in 2.56 milliliters of water at this temperature? Well, we want to find how many water molecules there are. So that's where we want to end up. It's the number of water molecules. And probably if I want to find molecules, I will have to have moles of water molecules. And what am I starting with? I am starting with 2.56 milliliters. 2.56 milliliters of water. And water is a pure substance, not a solution. So we can't work with molarity here. So if we were using our, our chart here, we would be starting with volume. This is of a pure substance. And this, in this case, is water, milliliters of water. This is where we're starting. Start. And then we're going to convert that into grams of water. We are going to convert that into moles of water. And then we are going to convert that into, over here, molecules of water. Okay, so that's going to be a 1, 2, 3-step problem. So, working our way forward now, we have milliliters of water, which we can convert into grams of water using the density. We have grams of water, which we can convert into moles of water. The conversion factor between grams and moles is the molar mass. And finally, converting between moles of water and number of water molecules, that is Avogadro's number. All right, let's do this. How many water molecules is equal to 2.56 milliliters of water times the density of water is 1.00 grams per milliliter. 1.00 grams per milliliter. So I need to cancel milliliters and find grams. So 1.00 grams per milliliter of water goes on the top. So we have now made it to grams of water. Next we need to find moles of water. So cancel grams of water and find moles of water. And I happen to know that the molar mass of water is 18.0. Oxygen is 16, 2 hydrogens at 1 each. That gives me 18. Handy to know, especially if you're calculating the molar mass of, say, a hydrate, because it has a certain number of waters, each of which weighs 18 grams per mole. All right. And now, finally, we need to go from moles of water, cancel moles of water, and we need to find the number of water molecules. Why did I write number? I don't know. Let's get rid of that. There we go. So we have 6.02 times 10 to the 23 water molecules per 1 mole. Do that calculation and we get 8.56 times 10 to the 24 water molecules. So that is a slightly more complicated example. A second slightly more complicated example, also on page 70. This is a second example on page 70. The density of strontium is 2.64 grams per centimeter cubed. Don't forget that centimeter cubed is another unit of volume. And also remember that 1 milliliter is equal to 1 centimeter cubed. You may not need to know that for this question, but it is super useful all the time, so don't forget it. What volume is occupied by 1.8 times 10 to the 24 atoms of strontium? All right, and so at this point we now have to say, well, our unknown is the volume, and let's give it in centimeters cubed because that's the volume unit we have, so we don't know how many centimeters cubed. That's our unknown. A conversion factor will be our density, 2.64 grams per centimeter cubed. That is a conversion factor. And we are told that we have 1.8 times 10 to the 24 atoms. That is going to be our initial quantity. So, using our map, we have atoms of strontium. And we actually, we just want strontium all the way across so we don't have to worry about going up and down. So we have atoms of strontium can become moles of strontium, which can become grams of strontium, which can become volume of strontium. All right, so that's going to be a 1, 2, 3-step process. Avogadro's number here. Moles and grams, that is our molar mass. Moles per, no, not moles per gram. Grams per mole. Oh, where's my eraser? There it is. Grams per mole. And going from mass to volume of a pure substance, we are going to use the density, which is grams per centimeter cubed here. All right, let's do this. How many centimeters cubed of strontium is equal to 1.8 times 10 to the 24 atoms of strontium? First, we need to find the cancel atoms of strontium and find moles of strontium. Second, we need to cancel moles of strontium and find grams of strontium. And finally, we need to cancel grams of strontium and find the volume of strontium, which we agreed was going to be in centimeters cubed. So find centimeters cubed of strontium. And let's go back. Conversion factor between particles and moles is 6.02 times 10 to the 23. Don't forget, if you're doing an AP exam, you're not going to use 6.02, you're going to use 6.022 times 10 to the 23. But we're not going to worry about that for now. 1 mole. Grams of strontium. Well, look that up on your periodic table. That is 87.6 grams of strontium per 1 mole. And we were given density in the question. Let's go find it. It was 2.64 grams per centimeter cubed. So we have 2.64 grams per centimeter cubed. And we get 99.9 0.2 centimeters cubed.